So today we are going to be looking at the introduction to firewalls, and we want to be able to understand what firewalls are. We have already looked at we have already looked at what it is briefly when it came to when we're looking at the common network devices and also the basic network sorry, I had to mute something. When you're looking at the basic network concepts, we also you probably looked at it when you are going through module 2, which deals with operating systems and host security, and part of host security you also looked at host firewalls. So today we want to be looking at the introduction to firewalls. During data communication, insecure factors may cause information leakage, incomplete information, unavailable information, etc. So therefore, firewalls are required during network deployment. We already looked at what a firewall is. Maybe I'll just throw back this question to you. What do you think a firewall is in your understanding and what we have looked at so far? Just a mic check and speak to me. Yes, Patrick, your hand is up.
Okay, mic check.
Yes, please.
Okay, a firewall can either be a software or hardware, which is used to block any unwanted traffic to enter and also to leave the network.
Okay. Manage and control our traffic, right? So thank you, Patrick. So in this course, this course introduces the history of features, typical networking modes, application scenarios, and the technical specifications of Huawei firewalls. Upon completion of the course, you will be able to understand the basic concepts of firewalls, understand firewall basic security policies, and also have a good command of firewall security policy configurations. So moving to the next slide, let us look at the firewall overview. We already looked at the firewall and we said originally a firewall was just that thing that was put, or a wall that was built between houses to prevent fire from spreading. The firewall technology is an important part of security technology because in this course, we're going to discuss mainly hardware firewalls. And hardware firewalls integrate security technologies to protect private networks or our computers from harm. So to do this, we use dedicated hardware structure, high-speed CPUs, and of course embedded operating systems, and also support high-speed interfaces on our local area network interfaces. Hardware firewalls are independent of operating systems such as HP Unix, Sun OS, and AIX, and NT. And computers such as IMB 600, 6000, and are common pieces. And hardware firewalls are used to solve network security problems in a centralized manner. They are capable of various scenarios and they provide efficient filtering. They also provide security features such as access control, identity authentication, data encryption, the VPN technology. We shall be looking at VPNs in module 4, and address translation, which I think will be the next chapter. So users can configure security policies based on their network environments or needs to prevent unauthorized access and also to protect their networks. The modern firewall system should not just be an entrance barrier, but it should be the access control points of our network, and all the data flows either entering or leaving our network should pass through the firewall that serves as a gateway for either our incoming or outgoing information. Therefore, a firewall not only protects the security of an intranet on the internet, but also protects the security of hosts on the intranet. And all computers in the same security zone configured on a firewall are considered to be trustworthy, and communications between them are not affected by the firewall. However, communications between networks that are separated by a firewall must follow the policies and the rules that you have configured on your firewall. So they help us to do logical area filtering. And they hide also the intranet structure and the security assurance. And also it helps us in proactive, keyword is proactive defense against the attack. So can the traffic that does not pass through a firewall be protected? That is what we are looking. Well, that's what we are trying to discuss earlier on. So you can have your firewall and you can place it in between your intranet or your trusted zone or your most trusted zone, and also the other networks, or that could also be the internet. So sorry, you can have it in your trusted zone. This is our intranet, and this is the internet or other networks, and we can have a firewall there to help us defend against attacks, to give us assured security, and also to help us hide our internal infrastructure. So when people send ARP packets or ping packets and they're not permitted to go through our firewall, they will not be successful. And this is what we want to look at in this chapter. So classifications of firewalls. Firewalls have been developed for 3 generations now. Their classification methods are various. For example, firewalls can be classified into hardware firewalls and software firewalls, either by form or standalone firewalls, and network firewalls by protection object. So, but the most classification method is by control mode. How are we going to be able to control our traffic? And network firewalls can protect the entire network in a distributed manner. And we can configure things like centralized security policies. We can configure like diverse security functions, and we shall be looking at these things later on. Maintenance, low security risk, and complicated policy configurations. All those features are supported when you're using a distributed firewall or a network firewall. So firewalls are classified into the following types according to access control, because we said it's a most common kind of classification. So we can classify our firewalls either by packet filtering firewalls, or by proxy firewalls, or by stateful inspection firewalls. We are going to look at them later on. So classification by packet filtering. By packet filtering, each packet filtering checks each packet at the network layer and forwards or discards packets based on the security policies. And the basic principle of packet filtering is to configure our ACLs. Who is familiar with ACLs? To configure our ACLs to filter data packets based on source or destination IP address, or either port number or identifier, and packet transmission direction in the data packet. So this is basically packet filtering. They're filtering the packet at the network layer, and they are using the access control lists to determine whether that particular packet is allowed to go through or it's not allowed to go in. So the packet filtering firewall is in simple design, easy to implement, and cost effective. Though its disadvantage is that, using the access control lists, there's complexity and length increases, because whenever you want to add a filter rule, you need to add a filter rule and add a filter rule, and it has to be two-way if you want both machines to communicate. So the performance generally decreases exponentially. So static AC rules cannot meet dynamic security requirements. Some protocols work in a dynamic environment and they cannot be supported by static SCL rules. And packet filtering does not check session status or even analyze data. So here, unable to associate data packets, unable to adapt to multi-channel protocols, and it does not check the application layer data generally. These are some of the disadvantages of using packet filtering. So when you get our packet here, it goes through our firewall. We check the IP layer and check the protocol, and of course the application layer. But we check and see, are we allowing this? If we are not allowing this kind of packet, then we are going to discard it, and then the data will as well as go through our firewall. So only packet headers are checked, but it does not go ahead to check our application layer to see what is the content of that packet and if it's going to damage our network or computers. So we look at proxy firewall classification by proxy firewall. Proxy is like an agent, someone who that works on something on your behalf, and the proxy applies to the application layer of the network. And proxy checks the services directly transmitted between intranet and internet users. After the request passes through security policy check, the firewall establishes a connection with a real server on behalf of the intranet or the internet users, and then forwards the internet users request and then sends a response packet returned by the real server to the internet user. So what the proxy firewall does, it's going to be like an agent. Like, you know what? Send me, I'll be able to do all the things on your behalf. So what do I want? I want to make a communication with PC or with our intranet server. I want to make communication with our file server. What do I need to do? Firewall is going to go ahead and it's going to perform security check on the requests, and if the check fails, then the connection is blocked. But if it is allowed, it will go ahead and tell this guy, hey, there's someone I know who wants to establish a connection with you on his behalf. So after this guy responds to the firewall and says after the check succeeds, the connection to the server is set up, and then this guy will also come back here and notify, hey, you initiated the connection, I want to let you know that the connection with the client after the check, so we can now be able to communicate. So this guy will send a packet to the firewall. The firewall receives the packet and will send the packet to the server on behalf of the internet user. And also when this guy replies, this guy will receive the packet and we will send it on behalf of the internet user. So everything is going through our proxy firewall. So the proxy firewall can completely control the exchange of network information and also the session processes achieving high security. But because everything is going through it, sometimes its software implementation limits its processing speed and therefore the proxy firewall is vulnerable to distributed denial of service attack. Imagine if everything is going through this guy and someone gets their botnet with their zombies and they decide to all initiate connections to this intranet. Don't you think this guy will run out of resources and will be unavailable anymore, and then we shall have our denial of service attack? So an application layer proxy must be developed for each protocol, and the development period really takes long. And there's also some kind of performance or bottlenecks. So we want to look at stateful inspection. This is quite interesting, so you pay attention to it and we're going to explain to it. But with stateful inspection, there's fast processing of subsequent, keyword to note, subsequent packets and high security. So stateful inspection is an extension of packet filtering technology, and packets are filtered based on connection status with each packet treated as an independent unit, and the historical association of the packet are considered. And all data flows based on reliable connections, that is TCP-based data flows, are processed in three phases: the client request, the server response, and client response. That is a three-way handshake. So this indicates that each data packet does not exist independently but closely related to the preceding and subsequent packets based on the status association, and the stateful inspection technology is developed. So basically, the stateful inspection firewall uses various session tables. It has session tables where it's going to be keeping its sessions. So it's going to use various session tables to trace activated TCP connections and sessions, and also pseudo UDP sessions. And the access control lists determine the sessions to be established. And the data packet is forwarded only when it is associated with a session. The pseudo UDPs are usually monitors, they just monitor the status and connection processes. So the stateful firewall intercepts data packets at the network layer, extracts the status information required by security policies from each application layer, and then saves the information to the session table. And the session table subsequent connection requests related to the data packets are analyzed to make proper decisions. Because they're using this, like we have already said, we have high security, and also we have fast processing of subsequent packets. So we have our packet here and it's coming through our server. The first packet is going to go through the firewall. It's going to go through our SCL and I'm going to check and see if either we have permitted it or we are going to deny the packet from going. So it's going to receive it. It's going to check the security policy and it's going to check the session information. If the status is incorrect, it's going to disregard. But once the status is set up and like this guy is allowed, it's going to go ahead and update the session table, and after updating the session table, it will send the first packet. But usually, remember, when you're sending data, our data is broken into packets, right? It doesn't go as a whole. It goes in form of different packets that are delivered sequentially until when they reach, and they are built back together to form our meaningful data. So what will happen when the first packet here comes, it's going to check and see if this packet is allowed or what is the policy saying. And once everything is okay, it's going to update the session data. So if all these packets have the same status of the first packet, it's not going to go through checking all those packets for all these packets. So I'm going to check through them. It's going to say, oh, these guys are part of this guy. Just like when you go somewhere and you go in your company vehicle, right? When you go in your company van, I don't know if you have moved with your company van and there's an event. Usually, they don't ask everyone. Sometimes they just don't ask everyone for tickets. They just ask you how many are you, and then they will let you in. Or even sometimes they don't have to check one by one. In some cases, they just let you in the moment you have gone as a company. Now, if you go individually and you get to the gateway, people will have to ask you one by one, and this is packet filtering. They have to ask you. But with stateful inspection, the moment they check the driver and has a license and the invitation letter, we are going to let in the bus go, which also has other people inside. So this is going to make sure that the subsequent people who are coming, we're not going to waste time checking all of them. We're just going to process them and treat them the same way we treated the first packet. This is what we are calling stateful inspection firewalls. So the firewall networking modes, we have different networking modes for the firewall, but basically there is mode 1. A firewall only forwards packets and does not perform routing. That is mode 1. The firewall can just basically forward packets and it does not do any kind of routing. And the two service networks interconnected by the firewall must be in the same network range. Yes. So if the firewall is just going to forward the packets and it's not going to do any kind of, these guys must be in the same network range if we want them to be able to send packets and we want them to communicate effectively. So they must be in the same network segment, and in this mode, the upstream and the downstream interfaces of the firewall work at layer 2. These guys only work at layer 2 if you're going to follow to do our if you're going to operate it in mode 1. So they only work at layer 2 and they do not even need to have IP addresses. This networking mode avoids the issues caused by topology changes and it deploy a firewall like a bridge on the network, and there is no need to modify the existing configurations because it's working like a bridge. Things are just going through it. It doesn't do any kind of routing. So the firewall filters IP packets and protects users on the intranet. Then that was mode 1. So there is also mode 2, and mode 2, a firewall is located between the intranet and the internet, and the upstream and the service interfaces of the firewall, they work at layer 3. Layer 1, we said they work at layer 2 with mode 1. With mode 2, we said they're working at layer 3 and must be configured with IP addresses. They must be configured with IP addresses. And they have to be in different, or they can be in different network segments. And the firewall performs routing on the intranet and also on the internet like a router. So when you have a firewall, it can do the layer 3 functionality of choosing the optimal routes and also forwarding or routing our packets. So in this mode, the firewall supports more secure security features such as network address translation, but the original network topology must be modified. For example, if the intranet users must not modify their gateway configuration or the router configuration on the router must be modified. Therefore, the design personnel should consider factors such as network reconstruction and service interruption between when selecting the networking mode. So this is mode 1 and this is mode 2. Mode 2, we said it works at layer 3. Mode 1, we said it works at layer 2. And we need to configure IP addresses or with different network segments on our firewall interfaces. And these guys can also be in different network segments. They can be in different network segments, and the router performs layer 3 functions to forward and deal with data. So the principle of firewall forwarding, want to see how packets are being forwarded. So when receiving a packet, the firewall obtains the header and compares the header with the specific rules and decides to either forward or to discard the packet. When it receives it, it's going to check, am I allowed to send this? No. If I'm not allowed, then I should discard. So the core technique of packet filtering is the access control lists, the ACL. So there's headquarter here, the unauthorized users, and they're trying to send packet. It was said, am I allowed to receive packets from this network? No. So therefore, discard this packet and it should not go through to our headquarters. If traffic is coming from our branch, we are allowed to have it. If this kind of traffic, please either block or allow. So as network security protection mechanism, packet filtering mainly controls the forwarding of various traffic on the network, and traditional packet filtering firewalls obtain header information like we have discussed, and then it will match that information with predefined packet filtering rules and forwarding or discard the packets according to the matching results. So as the packet filtering firewall matches the packets with packet filtering rules one by one and checks the packet, the efficiency is low because remember it has to check one by one as the packets are coming through. And currently we are saying that firewalls usually use the stateful inspection, which we have just looked at. Stateful inspection, they usually use the stateful inspection mechanism to check the first packet of each connection, and thereafter they release and they do not have to go through the subsequent packets. So if the first packet passes the check and it's matching the filtering rule, the file will just create a session and directly forward the subsequent packets according to those sessions. So firewall security policies, these are basically policies. Like you can have policies at your home, at your workplace, like in your organization where you're working, you have things that are governing on how you should treat something or how you should deal with something. So Basically, a security policies control traffic forwarding according to specified rules and apply integrated content security detection to traffic. The rules focus on packet filtering. And the major applications are security policies control network communications through the firewall, and they also control access to the firewall. So they do not only control the network communication through the firewall, but also how, because it would be pointless for you to have everything in check, but then people can easily control and manipulate your firewall. So it looks at both those things. The firewall security policy mechanism. Basically, this is the mechanism. You just have policies on your firewall. The incoming data flows or comes to your firewall. Someone is trying to send packets to your network, so the information will come. The moment it comes, it goes through these policies. Policy 0, 1, and you can have them as many as you want to have. And also you have your default policy. So policy 1 says permit subsequent operations of A, and also deny subsequent operations of B. So when the packets come, it's going to filter out only the packets of A, because we are only permitting subsequent operations of A. So A is going to come and A will be allowed to flow through our firewall and it will be permitted. But when the B packets come, they will be denied, because our policy here says when subsequent packets of B come, please kindly deny them, and then you have your policies. So the firewall first searches for the matching security policy. It looks through their policies, what applies to this packet. Do we have any policy or rule that applies to this packet? And if yes, then the firewall determines whether to allow the next operation. The firewall processes the data packet according to the rules defined in the policy. And by default, most of the actions that the firewall does is to deny the default action. So if you have not configured or set a policy, usually the default policy is to deny. So the functions of security policies, it is to filter traffic passing through the firewall according to the defined rules, and also to determine the next operation according to the keywords. So we want to look at the firewall interzone forwarding. We said that the firewalls have quite a number of packets, and these are the packets. But basically, we have our packet and we have our trust zone. We said the computers which are on the same network or behind the firewall or in the trust zone, and those that are on the other side of the firewall are what we are calling the untrust zone. So the packet is going to come and queries the routing table and queries the interzone packet filtering rules based on the interzone and check the direction to which the interface belongs. So it says policy 1, we are going to permit packets that are coming from 192.168.168.0, and if this is our IP for this packet, it's going to allow. And then we're going to tell it, you know what, you're going to go ahead and deny packets that are coming from this IP address, from this address. And if this guy was the one with that IP address, the packets would be denied. And the default interzone packet filtering rule is deny. Usually most of the firewalls, be it Cisco, Huawei, or any firewall, most of them, the default interzone packet filtering rule is to deny. So no session is matched, perform the first packet process it will go through, and if a session is matched, then it's going to use our stateful inspection mechanism, and then it will perform the subsequent packet processing. So if it's on the first packet, then look up the session table and see if we have allowed those ones, and then go ahead and process the packets. So querying and creating sessions. Basically, you query, query the session table. Is the session table matched? If it is no, check whether a session table can be created. This means that it is, passing our security policies, and then it will go ahead and create those things in our session table. Look at the network address, the packet filtering rules, the routing table, server map, and then it will create the session. If the session table was already matched and there was a a there's a first packet. It's going to just perform the security check and then update the session table, and then it goes ahead and forwards the packet. Stateful inspection mechanism, we have already looked at it, and we say that when the stateful inspection mechanism is enabled, a session can be created only when the first packet passes the inspection performed by the firewall, and subsequent packets are forwarded based on the session. And when the stateful inspection mechanism is disabled, if the first packet does not pass through the firewall, subsequent packets can trigger generation of session as long as they go through the firewall. So this is just basically an illustration about the first packet. It usually goes through, and if it passes the rules that are configured in the firewall, then the session table or the sessions can be created. So what is a session? We already looked at the session, and we are saying that they are basics. Session are the basis of a stateful inspection firewall, and a session is created for each data flowing through our firewalls. Yeah, all the data that is flowing through our firewalls, and with our use of our quintuple, the use of our quintuple, that is the source IP, destination IP address, source and destination ports and protocol numbers. They are used as key values, and a dynamic session table is created to ensure that security of data flows between the zones. And the next generation firewall extends quintuple with the two more other elements. That is the user data. It adds on user data and also adds on application data. Okay, our next generation firewalls, they extend the quintuple, they add on user data, and also they add on application data. So as they're storing data in our session table, we go ahead and store the user data and also the application data. So this is how the session looks like, and the packet, if the packet here, they're going to go ahead and create a session and say if the packet matches the session, then the firewall allows the packet to pass. So our session table will have something like this. It will have the source IP address containing the IP address of where that packet is coming from, the source port, and the destination IP address, and then the port number. So this already know if you're using 23, which protocol is this? Our network engineers?
Telnet.
Telnet. So someone is trying to access our server remotely, and then they're using the TCP protocol, and then it is user ABCD, and the application that they're using is Telnet. So basically, that is what is covered in our session table. And querying the session table, we'll look at this when we come to the practicals, but you just type in your console and say display firewall session table, and then it will show you the session things in your table and show you the protocol name, session numbers, VPN instances, and session table. Basically, the session table information will what be displayed to you. And if you want to display a detailed information about the firewall session table, you just add this word verbose at the end of this query, and then it will give you a detailed session table information. For firewall security policies and applications, we have already looked at the matching principle, and we said the firewall, when the first packet comes through, in the first packet process, the firewall matches the packet with the security policies. In the subsequent packet process, the firewall does not match the packet with security policies. So first packet comes through, it is matched with security policies, and say permit this, deny this, do ABCD. The default action is to allow, and if no session is matched, then perform the first packet process and be able to match it to security policies. And if the session is matched, then perform the subsequent packets, and they're not matched with security policies. They are just forwarded to the intended destination. So security policy matching processes basically just look at the source, and look at all these details, the quintuple, the user data, service data, application schedule. Come here, and after matching this, after checking our traffic and matching it with our security policy, then look at the action. What does the security policy say? Should we either allow or should we deny? If we were to deny, what response packet do we send? Do we put there that sorry, you're not allowed to access this, or just ignore, but just deny and ignore? And then if we are to permit, then you also go ahead and look through the profile. So we have the condition, action, and profile. If you are to permit, you can as well as go ahead and look through the profile. Is it antivirus? Is it intrusion prevention? Is it a URL or filtering or file blocking or data filtering, and etc and etc? So that entirely depends on what you want to achieve. So application of security policies, basically security policies, we can apply them to safeguard our networks and also to filter our networks conveniently. So compared with conventional security policies, the security policies of next generation firewalls can distinguish between employees from different departments based on the users' information that they add on our quintuple, and they can also distinguish between applications. Remember, we are also adding on an application header part on top of our quintuple. So we can either get to know whether it's a web inserting messenger or a game or Zoom, or depending. And if they're using the same protocol such as HTTP, we can also use ports to distinguish. So inspect content security and also block viruses and hacker intrusions for better protection of our internal networks. So we have our intranet here on this IP address. This is our network address, 192.168.0.0/16, and it's our marketing department. We have also our RID department. This, we said anything behind our firewall, they are in the trust zone, and everything that is the part of the network that our firewall is trying to protect us is in the untrust zone. So security policy 1 says if the traffic is coming from any source and maybe it's going to any destination, but the user is from marketing department, and if they're using the application of instant messaging and game, kindly deny, do not permit the guy to send the packet. So if this guy here, computer B, wanted to access some game, wanted to play Candy Crush, right? And is trying to access the internet somewhere there to play the game. Do you think his packets will be permitted to go through?
No.
No.
They will be denied. And if this guy here tried to access and play the game, do you think his packets will be allowed?
Yes.
Yes.
Yes,
But
it will
remember,
be
we don't
allowed.
have that security policy configured on our firewall, and we said the default policy is to what? To deny.
Deny.
Remember, yes, with access control rule, we must specify all the controls that we want, the control list that we want our firewall to process. But anyway, before we get there, so we have our marketing guy here, and security policy 2 says source address any, and if it's going to any, and if the user is in the R and D department, okay, using the HTTP protocol, we permit. So if this guy was trying to access the page of Huawei, the website of Huawei, huawei.com, do you think his packets will be permitted or denied?
Permitted.
It will
Permitted.
be
It will be permitted because, yes, because packets of HTTP are permitted in our security policy. So configuring the security zone on the web user interface, we said which IP address do we use when we want to access our web IP address, our virtual firewall? Which IP address do we?
192.168.1.
Dot what?
0.1.
0.1.
0.1. Perfect. So
1.
configuring the security zone, this is how you configure it. You just go there and add. You go through these slides when you have successfully set up the firewall. I won't go through them now because it makes no sense going through something practical and you are just saying things. So you just go through these slides. They are basically very easy. You just say add an address object, click on address, click on add, go ahead and type in the MAC addresses IPv4. We shall go through them when after configuring our firewalls. So I'll skip through this, but basically showing you how you can add a schedule, things that we shouldn't really pay a lot of attention and detail to. But for purposes of understanding, we shall just go through them. So example of configuring security policies, networking requirements. This is just basically an example. We shall look at it later on. And the process and also the command, some of the commands that you can use to query your security policies. We shall look at them when we get there. This is basically the user interface. So I want us to look at a protocol, which we are calling ASPF. So multi-channel protocol technology, in a single protocol, it uses only one port during communication. For example, port 80 for www or HTTP. But multi-channel protocol uses 2 or more ports for communication. For example, the FTP. Passive mode uses port 21 and a random port, which is non-static in nature. So how to only use packet filtering methods to precisely determine ports used by multi-channel protocols. Because multi-channel protocols use 2 or more ports, it makes it very hard. Now, like the random port, there's no way you're going to configure it in your HCIA and predetermine it because it's going to be random anyway. So it makes it difficult for us to use single channel, for us to use multi-channel protocols as far as ACL is concerned. So for protocols that use random ports, pure packet filtering cannot determine the data flows. So we want to look at ASPF, and which we are calling an application-specific packet filter. Application-specific packet filter, and is an advanced filtering technology that checks application layer protocol information and monitors the status of the connected application layer protocol. And for all connections of a specified application protocol, the ASPF maintains status information and dynamically determines whether to permit data packets to pass through the firewall or discard the firewall. So it dynamically creates and deletes filtering rules basing on what is available. And this is what you're calling the ASPF. It is a multi-channel protocol, and it helps us to monitor communication packets. It maintains information about connections in its own data structure and uses information to create temporary roles. That is ASPF, and ASPF supports multi-channel protocols. It is used to filter packets at the application layer. You have that, and it will send data control, and then to be able to dynamically either create or delete protocols. So in multi-channel protocols like FTP, the control channel is separated from the data channel, like you can see here. It's separated from the data channel, and the data channel is dynamically negotiated by the control packets. And to prevent data from being disconnected by such rules, like ACLs, a channel must be temporarily enabled, and this is why the server map is applied. We will also look at server map accordingly. So you can use like a session table, and either you can use the keyword session map table to see your session table, but all these things were shared already. You can get some time and go through them. So the generation of server map, basically this is generation of server map. How and when do we generate the server map? So we generate the server map, or server map entries are generated when the firewall forwards the packets of multi-channel protocols such as FTP, RSTP, and ASP after the ASPF is configured. So after ASPF is configured and the firewall is forwarding traffic of multi-channel protocols like FTP, then server map entries are generated. That is one way. The second way is static server map entries can be generated when NAT server mapping is configured. So when you configure NAT server mapping on your firewall, then we generate static server map entries. So we can also generate server map entries. Here we're calling them triplet server map entries. They're generated when the firewall forwards the traffic of simple traversal of UTB through NAT protocols such as SMN, and after when ASPF is configured. So triplet, after when you configure ASPF and you transfer you transfer the simple traversal of UTB through our NAT stan, then the triplet server map entries are generated. Then the fourth way of generating these entries, the dynamic map server entries are generated when NAT no part is configured. We shall be looking at NAT, so we shall be understanding what network address translation means. So when it is configured. Then support of multi-channel by port identification. We can also port identification map non-standard protocols ports to identify the application control ports. Basically, how to configure basic SEL, you just punch in that term, which shall be looking at them in the labs. The fragment check catch, the fragment catch function is used to catch fragments that arrive before the first fragment in the flow. And this function prevents the firewall from discarding fragments. So when the first fragment comes, this guy helps us to catch its fragments so that the server does not discard our fragments. Okay, so persistent connection. Why do we need persistent connection? Why are persistent connections required? Because of the aging mechanism of our firewall session table, problem caused by session aging mechanism to special services. So if no data is transmitted within some aging period of time, the session is disconnected. So imagine if under normal circumstances, sessions has been disconnected because there's no, maybe the network went off, maybe there's no connection, and when other packets come through when the network is back, but because a session has already been disconnected, these packets will all be discarded. Imagine you are downloading something and because of one reason or another, your network was off, and then the firewall closes the session, and when you come back, your packets are dropped. I think it would be pretty annoying. So that's why sometimes we need to configure and use persistent connection. Basically, if the interval of 2 consecutive packets of the TCP session reaching the firewall is longer than the aging time of the session, the firewall deletes the session information from the session, which is not good. So some firewalls support persistent connection function only on TCP packets. So to configure that, you go ahead and you set time of aging to persistent connection, and firewall long link aging time, you go ahead and increase it, and also you enable persistent connection on your firewall, and we will look at that later on. So quiz, which of the following situation will server map entries be generated? Which of the following situations will server map entries be generated? We have these different answers. Which one do you think will lead to the generation of server map entries? Yes, Charles, your hand is up.
C.
C, A, B.
Yes, A and B.
B.
Okay, we talked about all these things, right? We said it's NAT no part when it's configured, when NAT server mapping is configured, and also when ASPF is configured. We did not talk about persistent connection being configured. Okay, all right. So a firewall has 4 default security zones, and the security levels of the firewalls cannot be changed. True or false?
True.
It is true. We talked about that earlier on. Perfect. So that brings us to the end of the slides. Let me stop recording.